Welcome to Whispers of Time, a journey into the forgotten disaster that ended an age long before history began, where tonight you will step gently into the most forgotten moment in human prehistory, an ordinary morning when the sky, without warning, prepared to betray the world beneath it. You rise from your resting place, hearing the soft crackle of dying embers and the whisper of wind through the grass, everything calm and familiar, and yet something in you senses a faint tension in the air, a quiet unease you cannot explain. Scientists today believe that ancient people may have felt this very same shift before past catastrophes, pressure changing, animals growing restless, the horizon holding a strange stillness. And as you look up at the pale morning light, you have no idea that this peaceful world is only moments away from the first signs of an event that would turn the sky black and erase an entire age from memory. This is the world you've inherited. This is the only world you know. Your parents knew this world. Their parents before them knew versions of this world, though the climate has been gradually warming for thousands of years. The great ice sheets that once covered much of the northern regions have been retreating, leaving behind a landscape that's becoming greener, more abundant. To you, life seems stable. The world has its patterns. Follow those patterns, understand them deeply, and you can survive. More than survive, you can thrive. But on one particular morning, a morning that will be remembered in the very stones of the earth, in layers of dust and ash and mysterious particles that will baffle scientists for thousands of years, everything changes in an instant, not gradually, not over seasons or years, but in a single catastrophic moment that transforms the world forever. This is not a hypothetical disaster that might happen. This is something that actually did happen. This is something that shaped your ancestors' lives and, by extension, shaped everything about the world you live in today. Not gradually, not over seasons or years, but in a single catastrophic moment that transforms the world forever. This isn't a story that survived in written records or ancient texts. The people of that time didn't leave us detailed accounts, didn't warn their descendants in words that could be passed down. Instead, they left their story in the earth itself, in layers of sediment, in particles that shouldn't exist in nature, in the sudden extinction of entire species, in the abrupt abandonment of thriving settlements, in the desperate adaptation of human populations to a world that had suddenly become hostile and unforgiving. And it's only now, in our modern age with our sophisticated instruments and scientific methods, that we're beginning to read this story written in stone and dust and bone. This is the story of 12,800 years ago. This is the tale of a day when the sky quite literally turned black, when the world caught fire, when an entire age came to an end, and everything, from the climate to the animals that roamed the earth to the very strategies humans used to survive, was forced to transform overnight. The story begins not in a laboratory or a modern city, but in the minds of scientists who began noticing something strange. Throughout the 1990s and early 2000s, researchers examining sediment cores from around the world started to observe an unusual pattern. At nearly the same point in time, measured across numerous sites on different continents, there existed a thin but remarkable layer. This layer, now called the Younger Dryas boundary, or YDB, contains substances that seem unusual. Tiny particles that would require temperatures so extreme they could only be created under the most violent conditions. These particles, nanodiamonds, magnetic microspheres, particles of iridium and platinum, melt glass, appeared to tell a story of cosmic violence. Though it's worth noting that the scientific community remains divided on what these particles actually represent. Some scientists find the impact hypothesis compelling, others remain skeptical, pointing to alternative explanations for these materials. But here's what makes this so profoundly moving. This wasn't just an event that happened in some remote corner of the world and faded into geological time. This was a moment that reached out and touched human lives directly. It ended civilizations that were just beginning to flourish. It transformed the survival strategies of people who had wandered the earth as hunters and gatherers for hundreds of thousands of years. It forced them, almost overnight, to invent agriculture, to settle, to domesticate animals, to create the foundations of everything we recognize as civilization today. And perhaps most remarkably, our evidence suggests that somewhere, someone survived, that after the fires died down and the dust settled, humans looked at what remained and decided to keep going. They didn't quit, they adapted, they changed, they survived. And in that survival, they set humanity on the path that led to everything we are today. The conventional understanding of climate change, of extinction, of human history in that period, is that these things happened gradually. The ice melted slowly. Species adapted or died off over thousands of years. Civilizations rose and fell with changes in weather patterns that took decades or centuries to fully develop. But what if that's not the whole story? What if, at the precise moment when humanity was positioned to transform itself, when we were on the very edge of agriculture, on the threshold of civilization, something arrived from the sky that forced our hand? What if the most important event in human prehistory happened not because we slowly figured out farming was a good idea, but because we suddenly had no choice? This is the morning before the dark, before the sky turns black, before everything changes. Let us travel back to that moment and walk with our ancestors through the greatest catastrophe they ever witnessed. Let us understand what they endured, how they persevered, and what their story means for us living in our own uncertain times. To understand the day the sky turned black, we must first understand what the world was like before it happened. And it was a world very different from our own. You must imagine a planet still emerging from a long ice age. Not fully emerged, mind you, but waking up. The great glaciers that had covered much of North America and Europe were in retreat. The climate was warming, sea levels were rising. The world was in a state of profound transition, and this transition had been underway for thousands of years. Picture this in your mind. The moment we're speaking of is approximately 12,800 years before the present day. To put this in context, written history, the period when humans began recording their activities in words and symbols, wouldn't begin for another 2,000 years after this point. Writing wouldn't be invented until after the catastrophe and the recovery that followed it. So, we're in a time of genuine prehistory, a time before any human records existed. What we know about this period comes from archaeology, from the careful study of artifacts left behind, from analysis of bones and tools and settlement patterns, and from geology, from reading the story written in the Earth's layers. Think about North America at this time. Much of what we now call the Great Plains and eastern United States was still quite recently dominated by ice sheets so vast and so thick that they shaped the entire landscape. When these ice sheets began to melt, around 19,000 years ago, it was like opening the floodgates. Imagine water, massive, unimaginable quantities of water, suddenly unleashed across the continent. These meltwater pulses didn't happen smoothly. They occurred in surges, sometimes catastrophically. Great lakes formed behind the retreating ice. Lake Agassiz and the Baltic Ice Lake were among the largest bodies of fresh water ever to exist on Earth. Some of these lakes covered areas larger than all the Great Lakes combined. And where did this water go? Sometimes it drained back gradually, changing the landscape over time. But sometimes, when ice dams failed catastrophically, the water released all at once, creating floods of such magnitude that they reshaped entire regions in a matter of days or weeks. By 12,800 years ago, this process had been going on for thousands of years. The climate had stabilized into a warmer pattern. The catastrophic floods from melting ice were mostly in the past, though occasional surges still occurred. The landscape of North America had been thoroughly rearranged. Coastlines had changed as sea levels rose. Forests had expanded into regions that had been barren tundra during the last glacial maximum. The world, from a human perspective, seemed to be settling into a new and stable equilibrium. This world before the catastrophe was, in many places, quite abundant. North America, in particular, was a land of extraordinary megafauna, animals of immense size that would astonish a modern observer. Picture it: woolly mammoths roamed the grasslands. their massive frames and long tusks making them unmistakable. These weren't small creatures. An adult woolly mammoth could weigh as much as 4 tons and stand 12 feet tall at the shoulder. Their tusks curved elegantly, sometimes reaching lengths of more than 13 feet. They were adapted to cold, their bodies covered in thick fur, their ears smaller than their tropical cousins to minimize heat loss. They lived in herds, following seasonal migration patterns, traveling across vast territories in search of the grasses and other vegetation that sustained them. Ground sloths moved through the landscape, though these were not small creatures clinging to trees as modern sloths do. Some were as large as an elephant, weighing as much as 5 tons. They were ground-dwelling animals, moving slowly on their powerful hind legs, their massive claws used to pull down branches and dig for roots. The ground sloths were herbivores, relatively peaceful despite their enormous size, feeding on the vegetation of North American forests and plains. Saber-toothed cats prowled the landscape, hunting the large herbivores. These weren't quite like modern lions or tigers. They were more heavily built, with shorter tails and more robust bodies optimized for hunting large prey. Their canine teeth were the distinguishing feature, enormous teeth, up to 7 inches long, used to deliver fatal bites to their prey. They were solitary hunters primarily, though some evidence suggests occasional cooperation in hunting. There were camels and horses native to the Americas, strange as that sounds to modern ears, since we think of camels and horses as old-world animals. But in fact, both had originated in North America before spreading to other continents. In this period, they still thrived in their native continent. There were giant short-faced bears, standing more than 10 feet tall, far larger than modern grizzlies, and likely omnivorous, or primarily carnivorous. Dire wolves, with jaws powerful enough to crush bones, hunted in packs. These were not the sleek gray wolves of modern times, but rather massive, heavily built predators. Weighing up to 200 pounds, their jaws capable of exerting crushing force. More than 125 species of large mammals called this continent home. The landscape was rich with life, with megafauna that captured the imagination and still dominates our image of Ice Age America. But this wasn't actually an ice age at this moment. It was the warm period following the Ice Age. The ice sheets had retreated northward. The climate was pleasant and warming. These animals were in their element, thriving in an environment that suited them well. And among these great beasts walked humans. They had arrived in the East, America's perhaps 15,000 years earlier, or possibly much earlier still. The timeline is still debated among scientists, with some evidence suggesting human presence 20,000 or even 30,000 years ago. But by 12,800 years ago, when our story begins, they had spread across the continent and had developed distinctive hunting technologies. The most famous of these were the Clovis people, named after the town in New Mexico, where their distinctive spear points were first recognized and identified by archaeologists. The Clovis points showed remarkable craftsmanship. They were elegant weapons created from stone with great care and skill, representing the peak of spear point design for hunting large animals. The most distinctive feature was called fluting, a channel carefully worked from the base of the point, reducing its weight while maintaining its strength. This allowed the points to be hafted to spears in a way that made them devastatingly effective hunting weapons. The fluting served multiple purposes. It lightened the point, making the spear faster and easier to throw. It provided a mechanism for better attachment to the shaft, and it may have helped with penetration. The Clovis people showed a level of technological sophistication and understanding of material science that was quite advanced for the time. The Clovis culture appeared relatively suddenly in the archaeological record around 13,400 years ago, and then spread with remarkable speed across the continent. Within about 500 years, Clovis peoples were everywhere, from the Great Plains to the East Coast to regions as far south as Mexico. They were hunters of the megafauna. Evidence from kill sites, places where animals were hunted and butchered, shows them hunting mammoths and mastodons. Their archaeological sites are marked by those distinctive spear points. and often by the bones of the great beasts they hunted. The distribution of Clovis points is so widespread and happens so quickly that some archaeologists have called it a Clovis invasion, suggesting that Clovis hunters spread across North America rapidly, possibly because they were extremely efficient at hunting the large animals that other populations didn't specialize in. But Clovis wasn't the only human culture thriving at this time. There were other peoples with other technologies, other ways of organizing themselves. In the Pacific Northwest, along the coasts of what is now Washington, Oregon, and British Columbia, there were maritime peoples who were developing sophisticated fishing technologies and settling in larger, more permanent villages. In the Great Basin of what is now Nevada and Utah, there were peoples adapting to the more arid environments. In the Southeast, populations were developing their own distinctive technologies and settlement patterns. And in the Middle East, in a region that would later become known as the cradle of civilization, there were early settlements that were beginning to explore a new way of living, a way that would ultimately transform human society completely. On the banks of the Euphrates River, in what is now Syria, nestled in a landscape of rolling hills and fertile valleys, stood a settlement that would become famous in archaeological circles for the revolutionary transformation that happened there. It was called Abu Hureyra, and the people who lived there around 12,800 years ago were still hunter-gatherers in the traditional sense. But they were becoming more settled. They had found a location of such abundance that they had chosen to stay in one place longer than their ancestors typically did. The river provided water, the surrounding region provided game and wild plants. Life was good. The people of Abu Hureyra knew their landscape intimately. They knew which wild legumes grew where and when. They understood the seasonal pattern of grain growth. They hunted gazelle and other animals with practiced skill. They fished the river with methods honed by generations of knowledge. They gathered berries and nuts. The archaeological record shows that they had a sophisticated understanding of their environment and exploited it skillfully. They were not yet farmers. They didn't plant seeds and tend crops in the way we think of agriculture today. But they were beginning to settle more permanently, which meant they were beginning to become more dependent on understanding and managing local resources. They were experimenting with management of the landscape, with controlled burning to encourage certain plant growth, with careful harvesting to ensure resources continue to be available. This was a moment of profound cultural and environmental stability. The warming trend that had begun after the last glacial maximum was well underway. The climate was pleasant and predictable. The seasonal patterns were reliable. The forests were expanding into regions previously covered by tundra. The grasslands were rich with life. Humans had adapted brilliantly to every environment on Earth. In the Americas, they were becoming expert hunters of the largest land animals ever to exist. In the Middle East, they were building settlements and exploring more sedentary ways of life. In Africa, Europe, and Asia, countless peoples had adapted to their local environments and created viable, sustainable populations. This was the world before. This was the balance that had been achieved. This was the moment of apparent stability before the unexpected arrived. The plants flourished because the climate was stable. The animals thrived because their food sources were reliable. Humans prospered because they had learned to live in harmony with their environments. Everything was in an equilibrium that, looking back from our modern perspective, seems almost fragile. Because it was. All of this, every species, every culture, every adaptation that had been achieved, was about to be tested in a way that would have seemed impossible to anyone living at that time. Though, stable climate would shift dramatically. The abundant megafauna would face extinction pressure from which they couldn't escape. The foraging strategies that had worked for thousands of years would become inadequate. The world was about to change more rapidly and more completely than any generation in thousands of years would have thought possible. What no one could see, what no one could possibly have predicted, was approaching from the distant regions of space. It was a fragment of an ancient comet, broken into pieces over millions of years, traveling through the cosmic dark toward the planet we call home. It had no awareness, no intention. It was simply following the laws of physics. But when it arrived, it would change everything. Part 3. The Arrival of the Darkness. Word count 4,200. We don't know exactly what the morning looked like when it happened. Was it clear? Was there already a sense of something amiss? Some of our earliest evidence comes from the geological record, the physical materials left behind. What scientists have found suggests that the event was not subtle. The sky must have been dramatic in the moments before impact. Perhaps those who were paying attention to the world around them, who had learned to read signs in nature, as all pre-industrial peoples must, noticed something wrong. Did they see a brightness, a glow from the horizon as something hurtled through the atmosphere? Did the birds behave strangely, taking flight suddenly for no apparent reason? Did the animals sense something and flee to shelters, displaying an instinctive understanding of danger that their human hunters recognized but didn't quite understand? We can only imagine these last moments of normalcy, but the impact evidence tells us that what came was powerful beyond measure. Picture this in your mind. A comet, perhaps 50 to 100 kilometers in diameter, a massive collection of ice and rock and dust, is traveling through space on a collision course with Earth. But this comet has already been fragmented. It's not one solid object, but rather many pieces, some large, some smaller, all traveling together through the void like a swarm. They're following a trajectory that has been calculated by the gravity of the sun and planets for millions of years. They're hurtling toward Earth at velocities that are almost incomprehensible, speeds exceeding 20 kilometers per second, which is roughly 45,000 miles per hour. As these fragments enter Earth's atmosphere at such extreme velocities, the physics of the situation becomes cataclysmic. The atmosphere tries to slow these objects down. It provides resistance. The friction between the fragments and the air at such extreme speeds generates heat so intense that it would make our modern nuclear weapons seem quaint by comparison. We're talking about temperatures reaching thousands of degrees, hotter than the surface of the sun in some cases. The fragments don't make it all the way to the ground intact. Instead, they explode in the upper atmosphere in a series of air bursts. Scientists compare these explosions to the effect of a nuclear detonation, and not a small one. Some estimates suggest the explosions were equivalent to thousands of nuclear warheads detonating simultaneously across the planet. The shockwave radiates downward, the energy released in the form of heat and pressure so extreme that everything beneath is vaporized. Materials are melted, rocks are turned into liquid. The shock is so intense that it leaves permanent imprints on the molecular structure of materials, creating what scientists call shocked quartz, where the crystal structure itself is deformed by the pressure. We know this happened over North America. The evidence is clear. But the explosion wasn't a single event. It wasn't one comet hitting one location. Research suggests multiple airbursts occurred, probably more than one, strewn across different regions. Some may have occurred over North America, perhaps over the Great Lakes region, or over the Great Plains, or both. Others over Europe. Some evidence suggests that impacts occurred in other parts of the world as well, though this remains more speculative. What's clear is that the devastation wasn't localized. It was global. The entire planet was affected. Let's focus on one particular moment to help us understand what this must have been like. Let's say you're at Abu Hureyra when it happens. You're perhaps gathering water from the river, or working near the settlement in the morning sun, engaged in the mundane tasks of daily life. You're thinking about breakfast. You're thinking about the weather. You're thinking about what tasks need to be done today. And then, brightness. A flash that turns day into a kind of terrible noon, brighter than the sun has ever been, brighter than anything your mind has ever experienced. The brightness is so intense it's painful. It's not light as you know it, but something alien and wrong. Then comes the heat. Not the gentle warmth of morning sun on your skin, but a wave of extreme temperature that would kill instantly at ground zero and cause catastrophic burns for tens of kilometers in every direction. The heat is so extreme that it's almost not heat anymore. It's more like radiation, penetrating everything. Your skin would feel it, your hair would combust, any exposed flesh would be burned. You wouldn't have time to feel pain. The damage would be too rapid, too complete. Then comes the shock wave, a wall of air and pressure moving faster than sound itself. Imagine being struck by an invisible force with the power of a nuclear blast. Buildings don't withstand such forces. They're simply obliterated, torn apart by the pressure. People are knocked down with such force that bones break. Those who are close enough are killed outright. Those farther away experience the shock, the sound barrier breaking over them, the world suddenly becoming chaos. The shock wave flattens forests. It tears animals apart. It destroys everything in its path. And then comes the fire. Burning. Everywhere burning. Forests are ignited by the heat from the airburst. Grasslands go up in flames. Vegetation combusts spontaneously as the intense radiation washes over the landscape. The air itself seems to burn. Smoke rises into the sky, darker and denser than any storm cloud, blocking out the sun. This isn't a gradual process. This happens quickly. Within minutes, the world has transformed from daytime to twilight to something approaching darkness. The sun blotted out by the smoke and dust kicked up by the impact and the fires it triggered. The fires spread rapidly. Animals flee before the flames. Birds take flight. Larger animals that can't outrun the fire are consumed by it. The landscape becomes a hellscape of burning trees and grass and animal flesh. The smoke rises high into the atmosphere, mixing with the vaporized material from the impact itself, creating a vast cloud of dark particles that begins to spread around the planet. The global evidence for this catastrophe is preserved in what scientists call the Younger Dryas boundary, or YDB. This is a layer of sediment found at sites across the globe: North America, Europe, South America, the Middle East, Africa, Australia, and even in marine sediments from ocean cores. The layer is typically dark in color and carbon-rich, composed of soot and charcoal from the massive fires. The thickness varies from location to location, thicker near the impact zones, thinner farther away. But the layer is identifiable at hundreds of sites. But what makes it distinctive are the other particles mixed into this carbon matrix. Nanodiamonds, diamonds so small they can only be seen with an electron microscope, requiring magnification of tens of thousands of times, form under extreme pressure and temperature. These nanodiamonds appear in the YDB layer at concentrations far higher than would occur naturally through any normal geological process. In fact, the concentration of nanodiamonds in the YDB layer at some sites is thousands of times higher than in the layers above and below it. Tiny spheres of rock and metal that were melted in the extreme heat of the airburst and then cooled into these perfect little balls, ejected into the atmosphere and falling back to Earth across continents. Particles of platinum and iridium, elements so rare on Earth's surface that their presence in abundance is a clear indicator of an extraterrestrial source. Most of the platinum and iridium on Earth came down with the planet during its formation and sank into the iron core. What little remains in the crust is typically not concentrated in the upper layers where we can find it easily. The presence of these elements in the YDB layer, distributed globally, is a signature of cosmic origin. Particles of shocked quartz, where the structure of the crystal itself has been distorted by pressure so great that it leaves a permanent record in the molecular arrangement. When scientists examine shocked quartz under a microscope, they can see parallel lines running through the crystal. Planar deformation, features created by the shock pressure. These features don't form through any normal geological process. They form in impact events and in nuclear explosions. When scientists analyze these particles carefully, comparing them to materials formed in other impacts and in nuclear tests conducted in the 1950s, they found something remarkable. The shock fractures in the quartz from the YDB layer match precisely with the shock fractures created at the Nevada test site and at Hiroshima and other sites of nuclear detonation in the atmosphere. This wasn't evidence of a ground impact. There was no obvious crater, which would be expected if a large solid asteroid had struck the surface. Instead, this was evidence of an atmospheric explosion, an airburst. Multiple airbursts, probably, scattered around the globe. The dating of this event is crucial, and has been carefully verified by multiple independent research teams. Scientists use radiocarbon dating, measuring the decay of carbon-14 in organic materials, and other methods to determine when this layer was deposited. The results from multiple independent studies at dozens of sites point to a consistent date, approximately 12,800 years ago. Some studies narrow it further to 12,150 years ago. Others say around 12,900 years ago, depending on exactly how calibrations are done and how the radiocarbon date is converted to calendar years. But all of them cluster around this same moment in time, suggesting a genuinely synchronous global event happening within perhaps 50 years or so. A moment in geological time. Then begins something perhaps even more catastrophic than the immediate impact itself. The massive quantities of soot and dust kicked into the atmosphere don't fall back to Earth quickly. They stay aloft, circling the planet within days. Scientists who have studied global wildfire events talk about something called impact winter. Even a relatively small impact can throw enough particles into the atmosphere to reduce sunlight reaching the surface by a significant amount, causing cooling that lasts for months or years. But this wasn't a relatively small impact. Research suggests that as much as 10% of the world's forests and grasslands caught fire in this event, roughly 30 million square miles of the Earth's surface. This is an almost incomprehensible amount of burning. To put it in perspective, that's roughly the area of the entire Asian continent. The amount of smoke and soot generated was almost incomprehensible. We can look to historical events for comparison. In 1883, the island of Krakatoa in Indonesia erupted catastrophically. The explosion was so powerful that it was heard more than 3,000 kilometers away, one of the loudest sounds in recorded history. The explosion was visible from locations hundreds of kilometers away. It killed tens of thousands of people. The eruption injected enormous quantities of ash and sulfur dioxide into the atmosphere. The result was that global temperatures dropped by about 0.3 degrees Celsius in the following year. That was from a single volcanic explosion. The atmospheric effect persisted for several years, affecting weather patterns around the world. But the Younger Dryas event was likely many times more powerful than Krakatoa. The dust and soot veil would have been far thicker. The temperature decline would have been far more dramatic. Instead of a 0.3 degree drop, research suggests that global temperatures plummeted by as much as 12 to 15 degrees Celsius. In some regions, the decline was even more extreme. Some areas may have experienced temperature drops of 20 degrees or more. In some places, winters became so severe that the growing season essentially disappeared for several years. Think about what that means. If winter becomes so cold and lasts so long that summer never quite develops its full warmth, plants can't complete their growing cycles. Crops fail, wild plants don't set seed, entire food chains collapse. The sun became a dim disk in the sky. Midday appeared like twilight at best. At worst, the darkness was profound. Some evidence suggests that in regions close to the impact zones, the darkness lasted for days. The temperature began to plummet, not gradually but rapidly, dropping by tens of degrees within days or weeks. Temperatures that had been rising for thousands of years suddenly reversed. Winter became much colder and lingered longer. Summer never quite developed its full warmth. The climate shifted from the relatively stable, warm conditions that had defined the previous 1,000 years into something radically different. This new climate regime would persist for approximately 200 years, 1,000 years of a cold, dark, harsh world. To put this in perspective, this is longer than the entire span from the fall of Rome to the Renaissance. It's longer than the entire history of the United States. It's long enough that a person born at the beginning of this cold period would live their entire life in harsh climate conditions and never experience the warmer world that existed before. In the aftermath of the impact, silence. First the chaos of the moment, the explosions, the heat, the roaring of the fires, the wind from the shock waves that would have been like tornadoes. Then, as the dust settled and the fires continued to burn, but less intensely, a vast and terrible silence. The birds had fled or been killed. The animals that survived the initial blast were in shock or in flight, driven by panic and the need to escape the burning landscape. Many of the human survivors, if there were any, were also likely in a state of shock, trying to comprehend what had happened, trying to find shelter, trying to help those who were injured, trying to understand a world that had suddenly become incomprehensible. In the settlement of Abu Hureyra, the evidence is written in the ground itself. There are signs of intense burning like nothing the world has seen in recent memory. The structures that had been built with such care, mud brick buildings with multiple rooms, places where families had lived and eaten and slept, were destroyed. Some were burned, some were collapsed. The people who had lived there, who had made this place home, were suddenly scattered or dead. The archaeological record shows that the settlement was indeed occupied just before this dark layer of soot and charcoal and exotic particles appears in the soil. The tools they had used for hunting and gathering, the bones of animals they had eaten, the remains of their meals, all of this is preserved in the layer just below the evidence of the impact. But then, remarkably, there's evidence that the settlement didn't stay abandoned. This is crucial. Radiocarbon dating shows that after a brief period, perhaps just years or decades, the site was reoccupied. People returned, and the artifacts found in the layers immediately after the impact are the same as those found before. The same type of bone tools for processing food, the same kind of stone implements for hunting and gathering, the same techniques of making and using these implements. The continuity is striking. It suggests that it was the same people, or at least the same cultural group, who returned. Perhaps some community members had been away when the disaster struck, out hunting gazelle in distant locations, gathering specific plant resources at places they visited seasonally, or traveling to trade or visit relatives in other settlements. After the immediate catastrophe, they returned. They found their settlement destroyed, but the location itself still viable. The river still flowed, the region was still habitable, and they began again. But not quite the same as before. The environmental changes were too profound. The climate had shifted radically. The plants they had traditionally relied upon were no longer available in the same abundance. The wild grain that had been a staple was no longer as productive. The legumes that had been easy to harvest in quantity were no longer available in their previous abundance. The hunting patterns they had followed for generations were disrupted. The animals they hunted had either fled to other regions where the climate was more suitable, or perished from the extreme conditions. The world had changed, and they had to change with it. This is where the story of Abu Hureyra becomes central to our understanding of what happened in the aftermath of the impact. Because the people of Abu Hureyra didn't simply abandon the settlement. They didn't move to another location where life might be easier, traveling eastward or southward to regions where the climate change was less severe. Instead, they adapted, they innovated, they developed a new survival strategy, and, in doing so, they created something entirely new: agriculture. Not the agriculture of later civilizations with plows and organized fields, but the beginning of intentional cultivation. The first steps toward farming. The evidence for this is preserved in the seeds. Archaeologists excavating Abu Hureyra before the site was flooded to create Lake Assad in the 1970s, a dam project that unfortunately destroyed many important archaeological sites, recovered enormous quantities of seeds and plant remains. They established that, in the pre-impact period, the diet of the people of Abu Hureyra consisted of wild legumes, wild grains of various types, and fruits and berries gathered from the landscape. The remains show hunting of gazelle and other animals, fishing in the river, and the gathering of plants. They were skilled foragers with intimate knowledge of their environment and the seasonal availability of different resources. But in the layers immediately after the impact, this changes dramatically. The plant record shifts. The wild legumes and grains that had been staple foods are now less abundant. The plants being consumed are different, more drought-resistant species that could tolerate the harsher climate, And most remarkably, there's evidence that these plants were being deliberately cultivated. Wild rye appears to have been deliberately sown in prepared patches rather than simply gathered from the wild. Wheat appears in concentrations that suggest it wasn't simply being gathered, but planted and tended. Legumes show signs of deliberate cultivation, with evidence of harvesting patterns that suggest management rather than simple gathering. These are the earliest known instances of agriculture anywhere in the world, not the invention of farming as a response to hunger, or as a gradual realization over thousands of years that planting seeds was a good idea, not the result of experimentation and gradual discovery over generations, but rather agriculture as an emergency response, agriculture as a survival strategy forced upon people by environmental catastrophe. When the traditional foods failed, when the climate changed to the point that they could no longer rely on foraging in the way their ancestors had done, they were forced to innovate. They had to plant seeds and tend them, had to stay in one place long enough to harvest what they had sown, had to plan for seasons ahead, rather than simply responding to what the environment offered day by day. This wasn't a cultural revolution that happened over generations or centuries. The evidence suggests it happened quickly, within generations at most, possibly within a single generation. We're talking about people living their entire lives making this transition. Children born before the impact would have grown up learning to forage the traditional way from their parents. Those same people, as adults, would have witnessed the catastrophe and the climate change that followed, and would have been forced to develop new strategies. It's like an entire framework of knowledge and practice being discarded and replaced within the span of a human lifetime. When faced with the choice between staying and adapting or leaving their homeland to try their luck elsewhere, these people chose to adapt. They chose innovation. They chose to give agriculture a try. They chose to stay and solve the problem rather than abandon their homeland and hope to find better conditions elsewhere. And here's what's remarkable. They weren't alone in this. Similar evidence of the beginning of agriculture appears at other sites around the world at approximately the same time. In the Levant region, at places like Muribet and Halinchemi, both in what is now Turkey, there's evidence of cereal cultivation beginning right around the Younger Dryas boundary. Peas and lentils were being cultivated. The traditional explanation from archaeologists had been that agriculture developed gradually over thousands of years, that people slowly came to realize that planting seeds was beneficial, that it was a gradual process of trial and error that took generations to perfect. But the evidence from the Younger Dryas boundary suggests something very different. It suggests that agriculture was invented by necessity. It was forced upon people by a catastrophic climate change triggered by cosmic impact. But Abu Hureyra and the other early farming settlements in the Levant represent only one response to the catastrophe. In other parts of the world, the response was very different. Very often it was extinction. In North America, the megafauna that had dominated the landscape for thousands of years began to disappear. The woolly mammoths that had thrived in the cool grasslands of the continent began to decline. The ground sloths, the saber-toothed cats, the giant bears. These creatures that had evolved in a relatively stable climate suddenly found themselves in a world that had become hostile and unpredictable. The vegetation they depended upon was changing rapidly. The temperatures were dropping. The seasons were becoming more severe and less predictable. Many plants that had been food sources for the megafauna couldn't survive the new climate or couldn't grow fast enough to provide the quantities needed to feed such large animals. Some of these species managed to survive for a while. Evidence from fossils suggests that some populations persisted for centuries or even longer after the impact. Some woolly mammoths survived in refugia, protected areas where the climate was somewhat less severe than in surrounding regions. But the broader pattern across North America and beyond was one of extinction. By the end of the 1,200-year period of the Younger Dryas, the great megafauna of the Ice Age were gone, completely extinct. More than 75% of the large mammal species that had existed in North America disappeared in this period. This was an extinction event rivaling in severity the extinction of the Dinosaurs, though happening more slowly over centuries and millennia rather than instantaneously. The question of why these extinctions happened is still debated among scientists, and the answer is probably that multiple factors contributed. Some argue that human hunting played a major role. The Clovis hunters were efficient at hunting the megafauna. Perhaps they were so efficient that they drove the animals to extinction, an idea known as the overkill hypothesis. According to this theory, humans were like invasive predators encountering animals that had no evolutionary experience with such effective hunters, and they hunted them to extinction. But the evidence for this explanation is complicated and contested. The extinctions didn't happen uniformly across the world. In South America, they seem to have happened earlier than in North America, and differently than in other regions. In Siberia, woolly mammoths persisted longer, surviving in small populations until about 4,000 years ago, long after they had disappeared from North America. Some mammoths survived on Wrangel Island in the Arctic until only 2,000 years ago, after the beginning of recorded history. The global pattern is too variable to be explained simply by overkill by human hunters. Others argue that climate change alone can't explain it either. The climate had changed before, and these species had survived previous warming and cooling episodes. They were adapted to variability. They had survived the transition from the last glacial maximums 20,000 years ago, when the climate warmed dramatically. So, what made this time different? The answer, according to a growing body of evidence, is that this time it was catastrophic. The change was too rapid. The speed of the climate change was faster than the species could adapt to. Their food sources were disrupted too severely and too suddenly. And the combination of climate change, the fires triggered by the impact, the disrupted ecosystems, and human hunting together created a situation from which these species couldn't recover. The synergy of multiple factors, cosmic impact, climate change, ecosystem disruption, and human predation, created a perfect storm that these species couldn't survive. Think about what it would mean for a woolly mammoth population to suddenly face conditions where temperatures dropped by 15 degrees. The plants they ate couldn't grow. The caloric density of the vegetation available to them declined dramatically. They had to range farther to find food. They had fewer offspring because females weren't getting enough nutrition to reproduce successfully. Meanwhile, human hunters, though also affected by the climate change, were more adaptable and could shift their diet and hunting strategies. As mammoth populations declined, human hunters focused on them more intensively. The combination of scarcity of natural food, habitat loss, and hunting pressure proved to be too much. The loss of these animals changed the world. The Clovis people, who had adapted so successfully to hunting the megafauna, suddenly found their primary food source disappearing. Imagine if you had spent your entire life learning to hunt in a particular way, developing expertise in pursuing specific animals, making your entire identity and social status based on your hunting ability, and then suddenly that animal is gone. Your expertise is obsolete. Your society's entire structure is disrupted. The archaeological record shows evidence of this disruption. The number of Clovis spear points found at different time periods shows a dramatic decline right at the time of the impact. There are roughly 50% fewer Clovis points in the layers immediately after the YDB compared to the layers just before. This decline corresponds closely with the extinctions of the megafauna. This suggests that the Clovis culture was directly dependent on hunting these large animals, and when the animals disappeared, so did the Clovis way of life. The Clovis culture didn't disappear entirely, at least not immediately, but it changed, it reorganized, the people adapted. Some evidence suggests they began to focus more on smaller game animals, deer, elk, rabbits. They turned their attention more to fishing in rivers and coastal areas. They gathered plant foods more intensively. The specialization in hunting large mammals, which had been the defining characteristic of Clovis culture and the source of their success and expansion, was no longer viable. So they became more generalized foragers again, supplementing their diet with a wider variety of foods from the environment. But in North America, unlike in the Levant, where people responded to climate change by inventing agriculture, the response was generally to become more flexible foragers. The climate, while still cold and dry for much of the Younger Dryas period, didn't make foraging entirely impossible. There were still animals to hunt, plants to gather, fish to catch in the rivers. Life was harder, more precarious, but possible. The people developed new hunting technologies and new gathering strategies. They became more mobile, traveling seasonal routes to exploit different resources at different times of year. They persisted. In Africa, similar changes occurred. Some megafauna species that had thrived in African savannas experienced extinctions or near extinctions around the time of the Younger Dryas. The ecosystem was disrupted. Humans adapted. The populations that survived did so by being flexible, by expanding their diet to include smaller animals and different plants, by exploiting marine resources where available. Some regions of Africa were less affected by the climate change than others, and populations in the more fortunate regions had an easier transition. The loss of the megafauna must have been profound psychologically as well as economically for the human peoples who had depended upon them. These were not abstract animals. For the Clovis, hunters, mammoths weren't just a food source. They were the very center of their culture. Hunting them was probably a source of pride and identity. Young men would have spent years learning to hunt these dangerous, intelligent animals. The successful hunt would have been celebrated. The ritual practices and social structures of Clovis society were likely organized around the hunt. Stories would have been told about great hunters and great hunts. Status in the community would have been based on hunting prowess. The sudden disappearance of the animals they had built their entire way of life around must have been traumatic. It forced not just economic adaptation, but cultural transformation. It meant the end of a way of life. It meant the old stories and the old knowledge and the old status hierarchy were no longer relevant. New strategies had to be developed. New stories had to be told. New skills had to be learned, and younger generations would grow up in a world where mammoth hunting was a thing of legend rather than daily practice. And yet, humans persisted. The population declined. The evidence is clear. The number of archaeological sites in North America after the impact is lower than before. The number of tools found, the number of signs of human occupation, all suggest a reduction in population, possibly by as much as 50% in some regions. But they didn't go extinct. They survived, they adapted, they changed, and they continued on into the future, eventually becoming the ancestors of all the Native American peoples. The archaeological term for the dark layer at the Younger Dryas boundary sites is black mat. This is a poetic name for something that might appear mundane at first glance. It's a layer of dark sediment composed primarily of carbon, charcoal, and soot from the massive fires. But when you look at it more carefully, when you examine what's actually in this layer under magnification, when you analyze it with modern scientific instruments, it becomes clear that it represents something extraordinary. The black mat forms the boundary between two different worlds. Below it are the artifacts, the bones, the seeds and plants that represent the pre-impact world. Mammoth bones with cut marks showing where hunters had butchered them. Clovis spear points, carefully crafted, sharp and elegant. Wild grains and legumes that had been freely gathered. The material remains of a hunting and gathering culture that had worked for thousands of years. The tools show no signs of stress or emergency. They're made with the same care and craftsmanship as tools had always been made. Above the black mat is the post-impact world. Different plants in the pollen record. Different animals present in the faunal remains. Different human material culture. When you compare what's above the line to what's below, the change is stark. It's like two different worlds separated by a thin layer of dark sediment. At many sites across North America, the pattern is striking and consistent. Below the black mat, evidence of the Clovis culture, distinctive spear points with their characteristic fluting, the bones of hunted megafauna. Above the black mat, no more Clovis points, no more extinct megafauna bones. The culture has vanished. What replaces it are other spear point types, hunting different animals, using different techniques. The archaeological sequence shows a clear discontinuity. At other sites, like Abu Hureyra, the pattern is different. The settlement is disrupted, evidence of burning and destruction in the layer containing the impact materials. Buildings are damaged. There's a layer that shows intense burning, but then the site is reoccupied. The people return and begin farming. The transition from foraging to farming happened right at this black mat boundary, within generations, possibly within decades. One of the most studied black mat sites is Murray Springs in Arizona. When archaeologists excavated this site carefully, layer by layer, they found exactly what the impact hypothesis predicted: mammoth bones and Clovis spear points just below the black mat layer. The bones show cut marks where hunters had processed the meat. The spear points are scattered around as if this was a kill site where mammoths had been hunted and butchered. Above it, nothing. The site was abandoned. The Clovis people disappeared from this location at precisely the moment the black mat was deposited. Then, in the later layers, we see different cultures, different technology, different animals being hunted. The mystery of how some people survived the impact remains one of the enduring questions. At Abu Hureyra, it seems that some community members must have been away when the disaster struck. Perhaps they were on a hunting trip, days or weeks away from the settlement. Or perhaps they were collecting specific resources from distant locations, as foragers typically do. Foraging societies don't stay in one place all the time. They move seasonally to exploit different resources. Some groups might be traveling to distant locations for trade or social reasons when the catastrophe occurred. When they returned to find their settlement destroyed, they faced a choice. They could leave and try to resettle elsewhere, joining other communities or trying to establish themselves in new territories. Or they could stay and rebuild, adapting to the changed circumstances. The evidence suggests most who survived chose to stay. They adapted to the new climate. They developed new hunting and gathering strategies suited to the cooler, drier conditions. They changed their material culture, creating new tool types for hunting different animals and processing different plants. They changed their settlement patterns, moving more frequently or establishing different size settlements. They persisted through 1,200 years of difficult climate conditions. When the climate eventually improved again, around 11,600 years ago, when the world warmed and the dark clouds finally lifted, humanity emerged ready for the next phase of development. But the toll of this period can't be overstated. Human populations declined significantly across most regions. The archaeological evidence shows fewer sites, fewer artifacts, fewer people. The genetic evidence is even more remarkable. There's evidence of a population bottleneck in human genetics during this period. This means that human populations dropped so severely that everyone alive today is descended from a relatively small number of individuals who survived the Younger Dryas. It's one of the closest calls humanity has ever had. If the catastrophe had been slightly more severe, if the climate change had been slightly more extreme, if the conditions had persisted a bit longer, if the food sources had declined just a bit more, it's possible that the human species might have experienced a true extinction event. We might not be here at all. Think about what that means. Every human alive today is descended from people who survived the sky turning black. We exist because our ancestors made it through this catastrophe. We carry in our genes the resilience of survivors. This is not metaphorical. It's literally true. The genetic diversity of modern humans is reduced compared to what it would be if the Younger Dryas bottleneck hadn't happened. There are genetic variants that don't exist in modern humans that would exist if there hadn't been this severe population reduction. Our species came frighteningly close to extinction. The fact that we are here, that humanity persisted through this catastrophe and went on to build civilizations, to develop writing and art and science, is, when you think about it, remarkable. Our ancestors faced a crisis that tested everything they were. They were forced to change fundamentally, but they did it. They survived. And in surviving, they changed the course of human history. One of the most intriguing aspects of the archaeological evidence is the lack of direct oral traditions or written records of the event in later cultures. The catastrophe happened before writing was invented. It happened before organized civilizations with histories and myths and narratives existed. The people who experienced it survived, but the memory didn't survive in written or oral form that we can recover directly today. The event became geological memory instead, written in the rocks and soil, waiting for modern scientists with modern tools and sophisticated analytical techniques to read it. But there are hints in later mythologies. Many ancient cultures have flood myths, creation stories where the world is destroyed and remade. The Epic of Gilgamesh, one of the oldest written stories, contains a flood narrative. The Hebrew Bible contains the flood of Noah. Hindu traditions describe yugas ending in catastrophe. Native American traditions speak of world destruction and renewal. Some of these myths describe darkness and cold, fires and chaos. Scholars debate how much these later myths might preserve memories of real catastrophic events, including possibly the Younger Dryas. It's speculative, but intriguing. Is it possible that some faint memory of this catastrophe, passed down through hundreds or thousands of years in story form, shaped the mythologies that emerged when civilization later developed writing systems? We may never know for certain. Oral traditions can preserve some information across many generations, but they also transform and change. Local catastrophes get incorporated into the narratives. Religious meanings are layered onto them. By the time anything was written down, thousands of years later, the original event had probably been completely reshaped by cultural processes. But what we do know is that the survivors of the Younger Dryas impact proved that humanity is resilient. That faced with catastrophe, we don't simply perish, but adapt. We innovate. We transform ourselves to fit new circumstances. And in that transformation, we create the conditions for the next phase of human development. The cold persisted for a very long time, 12 centuries, 1,200 years. If you try to imagine what that meant for the people living through it, it's almost overwhelming. That's longer than the entire span of recorded European history, from the end of the Roman Empire to the Renaissance. It's longer than the entire existence of the United States as a nation. It's longer than the entire span from the invention of the printing press to the present day. It's long enough for a child born at the beginning of the Younger Dryas to grow old, die, and be remembered by descendants who lived their entire lives in that cold climate and might not even remember when it was warm. For plants and animals, 12 centuries is enough time for significant evolutionary change or adaptation. But it's not enough time for complete adaptation to new conditions when the change is so rapid and so severe. Species that thrived in the warm, post-glacial climate struggled in the cold. Many didn't survive at all, but those that could adapt, that could shift their ranges northward or southward depending on where they were, change their diets, or modify their behavior, persisted and evolved. For human populations, this millennium was a period of tremendous hardship, punctuated by moments of innovation and adaptation. Survival was not guaranteed. The population was reduced. Many communities probably disappeared entirely, leaving no trace except perhaps a few artifacts scattered and eventually buried by soil and sediment. But in some places, people endured and found ways forward. In the Levant, the people who had begun experimenting with agriculture continued and expanded these practices. The climate of the Younger Dryas, while colder than what had come before, was still survivable in this region. Agriculture required planning and labor, much harder work than foraging had been, but it provided a more reliable food source than foraging in increasingly uncertain environmental conditions. You could plant seeds in the spring, tend the plants through the growing season, and harvest them in the fall, knowing that you would have food. The variability of foraging was eliminated, replaced by the predictability of cultivation. The settlements that had emerged in the early stages of the Younger Dryas became more established. People committed themselves to staying in one place, to investing in cultivation, to building storage facilities for grain that would last through the winter months. They developed better tools for harvesting and processing grain. They developed techniques for storing grain so it wouldn't spoil. They built community structures that reflected the new way of living. The village, rather than the mobile camp, became the primary settlement type. This represented a fundamental shift in human existence. For hundreds of thousands of years, humans had been mobile. The strategy that worked was to move. When food ran out in one location, you packed up what you could carry and went to another. When seasons changed, you moved to follow the animals or the plants. Your possessions were limited to what you could carry. Your settlements were temporary. Your relationship to the landscape was one of use and movement rather than ownership and control. But agriculture required you to stay. You couldn't follow the mammoth herds if you had fields to tend. You couldn't move freely from season to season if you had crops in the ground that needed protection from pests and weeds. You couldn't abandon your settlement if the harvest was coming. This was a constraint, but it was also liberating. Staying in one place allowed you to invest in better housing. You could build more permanent structures that would last for years rather than temporary shelters. You could accumulate possessions. You could own things. But there was a compensation for this loss of mobility. Agriculture provided more calories per unit of land than foraging. In other words, a given piece of land could feed more people if it was farmed than if it was left wild for foraging. This density advantage meant that as populations grew, agriculture became not just viable, but necessary. The people who could farm could support larger populations than those who still relied on foraging. Over time, this meant that the agricultural regions grew, while the foraging regions remained more sparsely populated. Eventually, the farmers would expand into regions previously occupied by foragers, either displacing them or converting them to agricultural practices. The process wasn't smooth or uniform. There was probably significant resistance to agriculture. People who had cultural traditions tied to foraging and hunting might have resisted the new way of living. Agriculture is hard work. Foraging, when resources are available, might seem like an easier way to live, less labor-intensive, more flexible. But gradually, over generations, agriculture expanded. Not because everyone was convinced it was better, but because populations practicing agriculture grew larger and took up more territory. And populations still practicing foraging found themselves in more marginal environments or were absorbed into agricultural communities. During the Younger Dryas in the Levantine region of the Middle East, this transition from foraging to farming was accelerating. The domestication of plants, the process by which wild plants are selectively bred to become more productive, more reliable, and easier to harvest, was advancing. Wheat and barley were being cultivated. Lentils and peas were being grown. The seeds were being selected for larger size, for easier threshing, for higher yields. This wasn't consciously directed selective breeding in the way modern agriculture does it. People weren't sitting around thinking about genetics. But it was still selection based on practical results. The seeds that were easiest to harvest from plants that were most productive were the ones most likely to be replanted. Over generations, this created plants that were adapted to cultivation rather than wild growth. And around 10,000 years ago, near the end of the Younger Dryas, something else happened. Animals began to be domesticated as well. Sheep and goats, originally wild species living in the mountains of the Levant, began to be kept close to settlements. Wild cattle, the auroch, were being bred selectively to become more docile and more useful to humans. Wild pigs were being tamed. The process of animal domestication was just beginning. This combination of agricultural plants and domestic animals became the foundation for civilization. It provided enough food to support people who didn't produce food themselves: priests and rulers, craftspeople and soldiers, artists and scholars. It allowed for the accumulation of surplus goods, which led to trade, which led to economic specialization. It made possible the building of permanent settlements that grew into towns and cities. It allowed for the growth of populations to levels that would have been impossible with foraging alone. But the transition from foraging to farming also had costs that wouldn't be fully apparent for generations. The archaeological evidence shows that people who practiced agriculture were generally shorter, weaker, and more prone to disease than those who continued to forage. The shift to grain-based diets created nutritional deficiencies that didn't exist in more varied foraging diets. Grains are calorie-dense but lack certain vitamins and minerals. Disease became more common as populations became denser and lived in closer proximity to each other and to their domestic animals. Zoonotic diseases, diseases that jump from animals to humans, became more common. Life expectancy may have actually decreased with the shift to agriculture, at least initially. By skeletal analysis of skeletons from early agricultural societies, we can see evidence of nutritional stress, disease, and shorter average lifespans. Yet agriculture persisted and expanded because it allowed populations to grow. Even if each individual farmer was less healthy and shorter-lived than foragers had been, there could be more of them. The logic of population growth drove the transition forward, regardless of whether it made individual lives better. A population that doubles every few generations will eventually overwhelm a foraging population. The farmers, though individually perhaps less healthy, could eventually outnumber and outcompete the foragers simply through greater numbers. Then, around 11,600 years ago, something remarkable happened. The Younger Dryas ended, not gradually, but fairly rapidly. Over a period of just a few decades, or perhaps a few centuries at most, the climate shifted. The ice that had been advancing began to retreat. The temperatures that had been suppressed for so long began to rise. The climate shifted back to warmer conditions relatively quickly. The transition happened within a few centuries rather than gradually over thousands of years. It was the opposite of the abrupt cooling at the beginning of the Younger Dryas, but it was still remarkably rapid in geological terms. What caused this abrupt ending? The mechanisms are still being researched, but the most likely explanation involves changes in ocean circulation. During the Younger Dryas, the Atlantic meridional overturning circulation, essentially a giant conveyor belt of warm and cold water in the Atlantic Ocean, was weakened or disrupted. This disruption kept the North Atlantic region cold and limited the warming that should have been happening through other mechanisms. But around 11,600 years ago, this circulation restarted or restored to more normal levels. The warm currents began to flow northward again from the tropics. The climate started warming. The dark veil of particles that had been in the atmosphere slowly settled out and was removed. The sun became brighter in the sky. The world began to warm. The return to warmth was dramatic. The world began to shift back toward the conditions that had existed before the impact. The ice that had been advancing in certain regions began to retreat again. Forests began to expand again, moving northward in North America and northeastward in Europe. The climate became more stable and predictable. It's as if the planet took a deep breath after holding it for over 1,000 years. For human populations, this was transformative. The incentive to practice agriculture, which had been born of necessity in response to the catastrophic climate change, now had environmental backing. The warmer, more stable climate was good for farming. The seasonal patterns became predictable again. Crops could be relied upon to grow. This was the moment when agriculture truly began to flourish, no longer just a survival strategy, but a viable and productive way of life. In regions where agriculture had been struggling during the Younger Dryas, it could now expand and develop more fully. In the Levant, in Mesopotamia, in Egypt, in the Indus Valley, in China, in Mesoamerica, in multiple regions of the world independently, agriculture began to develop more fully. The people who had been experimenting with farming for the past 1,100 years now had better conditions. Agricultural productivity increased. Populations began to grow more rapidly. Settlements began to become larger and more permanent. The first towns emerged, places where hundreds of people lived together in organized communities. By around 10,000 years ago, the first true cities were beginning to emerge. Çatalhöyük, in what is now Turkey, was one of the earliest, a large settlement with hundreds of closely packed mud brick houses built side by side, so close together that people entered by climbing onto the roofs and descending through openings. Jericho, on the border of what is now Israel and Palestine, grew into a substantial town with defensive walls protecting the settlement. In Mesopotamia, settlements like Uruk began to grow and would eventually become the first true urban civilization, with temples and markets and organized government. This emergence of civilization, cities, writing, organized government, trade networks, technology, happened in the warmth and stability that followed the Younger Dryas. And while historians had traditionally explained this as a gradual, inevitable development that came from people slowly realizing the benefits of farming over generations, the evidence now suggests something very different. Agriculture was born from catastrophe. It emerged as a forced adaptation to a crisis. And in that emergency response, our ancestors set humanity on the path that led to everything civilization is today. The Younger Dryas catastrophe left marks not just in the geological record, but in human culture as well. Some of these marks are subtle, possibly coincidental. Others seem more direct and meaningful. When we examine the mythology and religious traditions that emerged in the civilizations that developed in the regions affected by the impact, we find recurring themes of destruction and renewal, of darkness and chaos giving way to order and light. In Mesopotamian mythology, one of the oldest written bodies of mythology we possess, we find the Epic of Gilgamesh. This epic, composed in the 3rd millennium BC, but based on even older oral traditions, contains a flood narrative where the gods decide to destroy humanity through overwhelming water. The few survivors who escape in a boat, similar to the later Noah story, go on to repopulate the world. Some scholars see in this narrative echoes of catastrophic events, possibly the Younger Dryas, or perhaps the subsequent flooding of the Mediterranean basin when sea levels rose after the Ice Age ended, or possibly other real flooding events that affected Mesopotamian civilizations. The Mesopotamian flood myths are very old and may preserve memories of multiple catastrophic events. The Book of Genesis, which later became part of the Hebrew Bible and Christian Old Testament, also contains flood narratives. Here again we find the theme of humanity being brought to the brink of extinction through natural catastrophe, with only a few survivors preserving the human species. The rainbow appears as a sign of covenant, of promise that such catastrophe won't happen again. The story may reflect memories of real floods, possibly including the Younger Dryas or subsequent events in the Mediterranean and Middle Eastern regions. In Hindu tradition, the concept of cyclical time includes the idea of the world being destroyed and remade multiple times. Different ages or yugas come and go, each ending in some form of catastrophe before the cycle begins again. The Puranas describe multiple ages of the world, each with its own characteristics, and each ending in destruction before the next age begins. There are flood narratives in Hindu texts as well. The story of Manu, who builds an ark to survive the great deluge under the guidance of a divine fish, parallels the Noah story from the Abrahamic tradition, but with different cultural details. In Chinese mythology, we find the story of Gun and Yu, related to control of the Great Flood. Yu eventually succeeds where his father Gun failed, using water management techniques to control the deluge rather than trying to simply block it. The story may preserve memories of real flooding events in ancient China, possibly including glacial melt floods or other catastrophic water events. In Native American traditions of the Americas, flood narratives and stories of global catastrophe appear in many different peoples' mythologies. Different tribes have different versions, but the theme of a world-destroying flood, from which only a few survive, is common. Some traditions speak of multiple creations and destructions of the world, with the current world being one of several that have existed and been destroyed. Now, it's important to be cautious here. Catastrophe is a common human experience. Floods, earthquakes, volcanic eruptions, droughts. Many cultures have experienced local catastrophes that shaped their mythologies. So, the fact that many ancient cultures have flood myths doesn't necessarily mean they all preserve memories of a specific global catastrophe, like the Younger Dryas impact. But there's something intriguing about the consistency of some themes. Many flood myths describe not just water, but also darkness, the sky turning dark or black, the sun being blotted out, extreme cold sometimes mentioned, the disruption of normal time and seasons, stars going out, fire before the flood in some versions, the survival of a small remnant of humanity who then repopulate the world being recreated or renewed after the catastrophe. These themes appear across cultures that had no contact with each other, separated by continents and thousands of years. It raises the question, could some of these myths preserve, however distorted by time and the vagaries of oral transmission, genuine memories of the Younger Dryas catastrophe? It's impossible to know for certain. By the time these myths were written down, sometimes thousands of years after the Younger Dryas, they had been modified and elaborated many times. Local catastrophes had been incorporated into the narratives, religious meanings had been layered onto them. The geological catastrophe of 12,800 years ago would have had to survive in human memory for 6,000 to 8,000 years before being written down, during which time it would have been constantly reinterpreted and reshaped by cultural processes. Oral traditions can transmit information across many generations, but they also change and adapt. What starts as a description of a real event can become mythologized over time. Yet the persistence of these themes across independent cultures is suggestive. It hints that somewhere in the deep memory of human culture, the catastrophe wasn't entirely forgotten. It survived in stories, in narratives, in cautionary tales passed down through generations. When writing finally emerged, some of these old stories were recorded, and they became part of the religious and cultural traditions of civilizations. Whether or not they're accurate records of the Younger Dryas, they suggest that apocalyptic thinking has deep roots in human consciousness. What's clear is that the survivors of the Younger Dryas didn't forget that the world could change catastrophically. They didn't forget that the climate could shift, and survival could be threatened. They didn't forget that humans were small and vulnerable in the face of natural forces. This understanding was woven into the religious traditions that emerged, into the stories people told themselves about the nature of existence. Many religious traditions include concepts of cosmic catastrophe and renewal. The idea that the world can be destroyed and remade appears in traditions from different parts of the world. It also affected how humans related to the natural world. The shift from foraging to agriculture represented not just a change in economic strategy, but a change in the human relationship to nature. Foragers see themselves as part of nature, adapting to what nature provides, integrated into ecosystems. Farmers see themselves as controlling nature, reshaping the landscape to suit their needs, dominating nature rather than being part of it. This shift in consciousness may have been accelerated by the Younger Dryas experience. When nature becomes hostile, when the climate turns against you, when the natural world threatens your survival, the response is to fight back, to take control, to refuse to be passive victims of natural forces. Agriculture, in this sense, can be seen as a kind of defiant human response to catastrophe. We will not simply accept what nature provides and adapt to it passively. We will reshape it. We will plant what we want to grow. We will domesticate animals for our use. We will build settlements where we choose, with permanent structures that assert human dominance over the landscape. We will create order from the chaos that nature represents. We will control nature rather than being controlled by it. This defiance, this determination to refuse to be passive victims of natural forces, may be one of the most important legacies of the Younger Dryas catastrophe. It propelled humanity towards civilization. It made us take control of our environment rather than being controlled by it. And while this brought great benefits, technology, culture, the ability to support large populations, art and music and literature and science, it also brought costs that we're still reckoning with today. The domination of nature has brought environmental degradation. The focus on control and order has sometimes led to rigidity and inability to adapt. But the impulse came from something profound, a determination born in catastrophe to never again be completely at the mercy of nature's whims. For most of recorded history, the Younger Dryas catastrophe was completely unknown. The geological layers existed, buried in the earth, but no one knew what they meant. The extinction of the megafauna was documented through fossil records as paleontologists studied bones and teeth and skeletal remains, but it was explained through different theories. The overkill hypothesis was the dominant explanation among paleontologists throughout most of the 20th century, the idea that human hunters had simply hunted the large animals to extinction. The sudden emergence of agriculture in the Middle East was taken as evidence that humans gradually figured out farming was a good idea, that a cultural transformation happened relatively quickly through invention and experimentation. The pieces of the puzzle existed, but weren't recognized as pieces of the same puzzle. It took modern science, with its sophisticated dating methods and its ability to analyze particles at the microscopic and even atomic level, to bring them together and realize they formed a coherent picture of a genuine global catastrophe. The story of the rediscovery of the Younger Dryas impact begins in the 1990s. A team of scientists, including Alan West, Richard Firestone, and others at various institutions, began examining sediment cores from around the world. They were looking for evidence of past impacts, using methods that had been developed for detecting extraterrestrial materials, techniques that had been used to study the extinction of the dinosaurs, to analyze the Chicxulub impact crater in Mexico, to understand how cosmic impacts affected Earth's geology. They found something unexpected. At multiple sites across North America, in the layer that corresponded to the time of the Clovis extinction, they found particles that shouldn't be there, nanodiamonds, shocked quartz with the characteristic deformation patterns, platinum and iridium, melt glass, material that had been melted by extreme heat and then cooled, the same particles that appear at impact sites around the world, the same particles that were produced by the nuclear bomb tests at places like Alamogordo and other test sites in Nevada, the signatures of cosmic impact and extreme heat. These findings were controversial at first. The established understanding of how impacts worked was that large asteroid impacts created obvious craters. The Barringer crater in Arizona, a nearly 50,000-year-old impact crater that's about a kilometer across and 175 meters deep, was well known. The enormous crater in the Yucatan Peninsula, where the asteroid that killed the dinosaurs struck 66 million years ago, was discovered in the 1990s. These were the paradigms. An impact should leave an obvious mark on the landscape, a visible scar that couldn't be missed. But this new understanding suggested that large impacts don't always leave obvious craters. If the impacting body is fragmented into many pieces, if it explodes in the atmosphere rather than hitting the ground, the evidence is much more subtle. It's written in tiny particles spread across the global atmosphere. It's written in the burned and shocked materials left behind. The impact that creates the most global disruption, the atmospheric explosion that sends particles around the planet, is actually the one that leaves the least obvious crater, because most of the energy is released in the upper atmosphere rather than at ground level. As more and more research accumulated, the case became stronger. Scientists at dozens of institutions independently conducted research on Younger Dryas boundary sites and confirmed the findings. The particles were really there. They really did date to 12,800 years ago. They really did match the characteristics of impact debris. Multiple research teams using different methods and working independently came to the same conclusion. At the same time, other researchers were working on understanding what happened to human populations around this time. Archaeologists were mapping the distribution of Clovis sites and noticing that they seemed to disappear right around the time of the Younger Dryas boundary. The disappearance of Clovis culture coincided precisely with the YDB layer. The extinction of megafauna corresponded with the impact layer. The beginning of agriculture in the Middle East started right at the impact boundary. The pieces fit together perfectly. What had seemed like separate phenomena, extinction, cultural change, agricultural revolution, could now be seen as different aspects of a single global event. By the early 2000s, the evidence had become compelling enough that major scientific institutions and funding agencies began supporting research on the Younger Dryas impact hypothesis. Universities created research programs dedicated to studying it. The University of Oregon, UC Berkeley, various institutions around the world began funding research on the YDB layer and its implications. Papers began appearing in major scientific journals with peer review, where other scientists scrutinized the work carefully before publication. The hypothesis moved from being a marginal idea promoted by a few researchers to being a subject of mainstream scientific inquiry. Major scientific conferences began hosting sessions on the Younger Dryas impact. The idea became respectable in scientific circles. There's still debate about some aspects of the hypothesis. Some scientists argue about the exact nature of the impacting object. Was it a comet? A fragmented asteroid? How many fragments were there? Where exactly did they strike? Over North America? Over Europe? Over both? Some of the details are still being worked out. Some researchers propose multiple impacts at different locations. Others suggest a single swarm of fragments from a comet that broke apart as it approached Earth. These are legitimate scientific debates about the specifics. But the core finding, that a major impact event occurred around 12,800 years ago and had significant consequences for human populations and ecosystems, is now widely accepted in the scientific community. Major peer-reviewed journals have published papers on the evidence. The Geological Society of America has discussed it. The American Geophysical Union has had sessions on it. While some scientists remain skeptical, the preponderance of evidence supports the hypothesis. The implications are profound. It means that one of the most important transitions in human history, the shift from hunting and gathering to agriculture, wasn't a gradual cultural development that happened over thousands of years through trial and error and slow realization. Instead, it was triggered by an environmental catastrophe. It was a forced response to climate change caused by cosmic impact. This changes how we think about human innovation and cultural development. It means that some of our most fundamental changes came not from free choice, but from necessity. It means that humanity came far closer to extinction than we usually realize. That we were brought to the brink and only survived through adaptation and resilience. It means that we're descended from an incredibly small number of survivors, that our species passed through a genetic bottleneck, where for a time there were only perhaps millions of humans left on the entire planet, concentrated in certain regions that were less affected by the climate catastrophe. It means that the climate is capable of changing far more rapidly than we might have thought before we understood the Younger Dryas. It shows that climate can shift dramatically, and suddenly, not gradually, over centuries, but over decades. And it shows the kinds of disruptions that rapid global climate change can cause: extinctions, the collapse of existing food sources, the forced adaptation of human populations to new environmental conditions, the complete reorganization of ecosystems. This last point has particular relevance for our modern world as we grapple with climate change driven by human activities. The Younger Dryas shows us that the climate can shift dramatically and rapidly. It shows us the kinds of disruptions that global climate change can cause. While the Younger Dryas was caused by cosmic impact, the climatic effects were similar to what we might expect from other large-scale global disruptions. The mechanisms are different, but the results are comparable. Rapid temperature change, disrupted weather patterns, failures in food systems, species extinctions. What then is the legacy of the day the sky turned black? What does the Younger Dryas catastrophe tell us about ourselves, about human nature, about our place in the universe? What can we learn from people who lived through a disaster so profound that the sun went dark and the world turned cold? First, and most obviously, it tells us that Earth is not a safe place. Catastrophe comes from the sky. It comes without warning, and when it arrives, the consequences are global and severe. The comfortable assumption that we're protected from cosmic threats, an assumption that modern humans often make, living in our climate-controlled buildings and protected from the elements, is a fiction. We're on a planet that orbits in a cosmos full of potential hazards. We live under a sky through which rocks and ice travel. We're vulnerable. But vulnerability, when recognized, can be a source of wisdom rather than despair. The Younger Dryas catastrophe, as terrible as it was, didn't destroy the human species. We survived it. And we didn't just survive passively. We adapted actively, we innovated, we transformed ourselves. In that transformation, we didn't lose our humanity. We actually discovered new human capacities. We discovered that we could do things we'd never done before. We could plant seeds and tend them. We could build permanent settlements. We could organize larger social groups. We could accumulate knowledge. We could transform ourselves and our societies in response to necessity. Second, the Younger Dryas tells us about the resilience of human populations. Faced with the loss of the animals they had based their entire hunting strategy on, the Clovis people didn't simply collapse and disappear. They changed. They adapted their hunting patterns to the focus on smaller animals. They incorporated more plant foods into their diet. They persisted through 12 centuries of harsh climate. In the Levant, the people of Abu Hureyra invented agriculture. They didn't give up and abandon their homeland. They found a way forward. This speaks to something deep in human nature. We are, at our core, creatures of adaptation. We are problem solvers. We innovate under pressure. Give us a catastrophe and we don't sit down and wait to be rescued. We work, we change, we find new ways to survive and thrive. This capability is in our genes, in our culture, in our very essence as a species. Our ancestors proved this 12,800 years ago, and that same capability runs through everyone alive today. Third, the Younger Dryas shows us the profound interconnectedness of natural systems. A cosmic impact that occurred in the upper atmosphere sent particles around the globe and disrupted climate everywhere. The extinction of animals in North America affected human populations on other continents through disrupted food webs and ecosystem changes. The climate disruption in one region had impacts on all regions. The plants that couldn't survive the new conditions disappeared from some places and persisted in others, creating a patchwork of different ecosystems. This is a lesson that remains true today. We live on an interconnected planet where what happens in one place affects everywhere else. Climate disruption in one region creates ripple effects across the globe. Extinction of a species in one place changes ecosystems elsewhere. We're all connected. Fourth, the catastrophe illuminates the role of contingency in history. If that comet fragment hadn't struck at precisely the moment when human populations were beginning to settle and explore agriculture, everything would have been different. Without the forced climate change and the loss of megafauna, would agriculture have developed at all? Would humans have eventually figured out farming on their own through gradual experimentation? Or would we still be hunter-gatherers, living more lightly on the land with different social structures and different technologies? We can't know, but it raises profound philosophical questions about causation in history. We tend to explain historical change through human agency. People made choices, had ideas, pursued goals, and all of that is true. But the Younger Dryas reminds us that history also unfolds through forces beyond human control. A cosmic impact 12,000 years ago shaped everything that came after. We are all, in some sense, descendants of survivors of an ancient catastrophe. The course of human civilization was set by an event that happened in the upper atmosphere and couldn't have been predicted or prevented by any human action. Fifth, the Younger Dryas catastrophe is humbling. It reminds us that we are not the dominant force in nature. Despite our technology and our cities, and our sense of control, we can be affected by events entirely beyond our power to prevent or control. A comet fragment from space can disrupt our food sources and force us to completely reorganize our societies. Climate change can happen so rapidly that species can't adapt fast enough. Nature, in its largest manifestations, overwhelms us. We're not in control. We're passengers on a planet that's subject to forces far greater than ourselves. Yet, this humility is balanced by another, a message: resilience. We survived. And we did more than survive. We eventually thrived. The agricultural revolution that was forced upon humanity by necessity became the foundation for all of civilization. The technological achievements of human culture grew out of that forced adaptation to catastrophe. Our cities, our art, our science, our music, all of it traces back ultimately to the forced innovation that began when people had to figure out how to farm because the old ways of foraging no longer worked. There's a lesson here for our contemporary world. We face climate challenges that will require significant adaptation and innovation. Our food systems may be disrupted. Our habitats may become less hospitable. We may need to fundamentally reorganize how we live. Climate patterns that we've relied on for agriculture are shifting. Species are going extinct faster than at any time since the dinosaurs. Water resources are becoming less reliable in some regions. But if our ancestors could adapt to a global catastrophe that killed off the vast majority of large animals and made the climate hostile for over 1,000 years, and emerged from that catastrophe to build civilizations, then we too can find ways to adapt and transform. The question is not whether we can adapt. Clearly we can. Our ancestors proved that. The question is how quickly we can adapt, and whether we can do it with less suffering than the Younger Dryas survivors experienced. They had no choice. They didn't choose to face catastrophe. They simply endured it. But we have the advantage of knowing what's coming, of understanding the science, of being able to plan ahead. We have the advantage of learning from our ancestors' example and from the accumulated knowledge of human civilization. As we come to the end of this long journey through catastrophe and survival, through darkness and adaptation, it's worth taking a moment to reflect on what our ancestors' experience can teach us. What wisdom can we extract from a story that happened so long ago that written history hadn't even begun? The people who lived through the Younger Dryas catastrophe didn't have the benefit of scientific understanding. They didn't have the periodic table or the theory of relativity. They didn't have chemistry or physics as formal disciplines. They didn't know what had caused the darkness and the cold. They didn't understand atmospheric physics or climate systems. They didn't know that a comet from space had disrupted the planet's climate for over 1,000 years. They didn't have instruments to measure temperature or predict weather patterns. They simply knew that the world had changed, that the sun had gone dark, that the temperature had dropped and kept dropping, that the animals they hunted were disappearing, that the plants they gathered were no longer abundant, that survival was becoming difficult, that they had to do something different or die trying. And they responded to this not with despair or resignation, but with action. They problem-solved. They tried new approaches. They moved to new locations. They developed new technologies. They invented agriculture. They survived. This response came from something deep in human nature, a refusal to accept defeat, a willingness to change, an ability to imagine and implement new strategies. There's a kind of wisdom in this response that transcends the specific circumstances of the Younger Dryas. It's a wisdom about how to meet catastrophe. Don't deny that it's happening. Don't pretend things are the way they used to be. Acknowledge the change and respond to it. Innovate. Be flexible. Try new approaches. Be willing to transform your way of life if necessary. The agricultural revolution that emerged from the Younger Dryas catastrophe was not something anyone planned. It wasn't the result of a committee meeting where people sat down and decided to invent farming. It emerged from the necessity of survival in changed circumstances. People tried new things because the old ways didn't work anymore. Some of those innovations succeeded. Those successes were built upon and expanded. Over generations, experimentation led to genuine agricultural practices. This is how human progress typically happens, not through grand planning or visionary genius, but through trial and error, through experimentation forced by circumstance, through the accumulation of small innovations that together add up to major transformations. A person tries something. It works better than the alternative. They do it again. They tell others about it. Others modify it. Over time, something new emerges. This is the process of cultural evolution, just as biological evolution works through random mutation and natural selection. In our contemporary world, we face challenges that will require innovation and adaptation. Climate change, resource depletion, technological disruption, social inequality, these are the challenges of our age. And like our ancestors facing the Younger Dryas, we will need to be flexible, creative, and willing to transform how we live if necessary. But unlike our ancestors, we have the advantage of knowing the direction of change and having some ability to guide it. But there's another wisdom from the Younger Dryas survival story that we shouldn't overlook. It's the wisdom of persistence. For 1,200 years, human populations endured harsh climate conditions. They didn't give up. They didn't abandon hope. Generation after generation, they lived through difficult circumstances and continued forward. They raised children in a cold, dark world and told them stories about better times and hopes for the future. They persisted. This long patience, this willingness to endure hardship and keep going, is perhaps as important as innovation and adaptation. Change happens, but it happens over time. Civilization emerges, but it takes generations. The benefits of survival accumulate slowly. This kind of long-term perspective, the willingness to work on problems that will take decades or generations to solve, is something we desperately need in the modern world. When people think about climate change or other large-scale global problems, they often feel paralyzed. The problem seems too big, the solution too distant, the change too slow. But the Younger Dryas survivors showed us that humans can work on long-term problems over generations. They can make progress even when the final solution won't be achieved in their lifetime. They can make changes that will benefit their children and grandchildren even if they won't see the final result themselves. This is perhaps the greatest gift we can receive from studying our ancestors' experience of catastrophe. Not despair or resignation, but hope grounded in evidence. Not blind optimism, but resilience based on knowledge of what humans have endured and overcome. Not a false sense that everything will be fine, but a realistic assessment that we can face challenges and adapt to them. There's also a humility in this. The Younger Dryas survivors didn't overcome the catastrophe through superhuman effort or brilliant innovation alone. They survived because they were flexible, because they were embedded in communities that supported each other, because they drew on thousands of years of accumulated knowledge about their environments, because they made mistakes and learned from them, because sometimes they got lucky, because they kept going even when things seemed hopeless. This humility is important. We tend to think of progress as coming from individual genius, the brilliant inventor, the visionary leader, the revolutionary thinker, and certainly those play a role. But most progress comes from the accumulated efforts of ordinary people doing their best in difficult circumstances. Most of human achievement comes from millions of people making small improvements, adapting, persisting, working together. Our ancestors in the Younger Dryas weren't geniuses. They were ordinary people facing an extraordinary crisis. And they managed to not just survive, but to lay the foundation for everything that came after. We are their descendants, and we carry that capacity for adaptation and persistence in our genes and in our culture. We have additional advantages: knowledge, technology, the ability to communicate across vast distances, the accumulated learning of all of human civilization. We have more resources to bring to bear on our problems. What our ancestors achieved with stone tools and oral traditions, we might accomplish with our modern capabilities. We began this journey in the moment before the sky turned black. We walked through the catastrophe and its immediate aftermath. We saw how it disrupted civilizations, ended species, forced humanity to transform itself. We witnessed the slow emergence from darkness as the climate gradually warmed and our ancestors rebuilt their lives on new foundations. We traced the emergence of agriculture and civilization from those ashes. We explored what the catastrophe might mean to us, living thousands of years later. Now, as we conclude this long journey into deep time, it's worth asking, what does this ancient catastrophe mean to us? Why should we care about something that happened 12,800 years ago? On one level, it's a fascinating scientific puzzle that researchers are still working to fully understand. How many impact fragments were there? Exactly where did they strike? What role did the impact play versus other forms of climate forcing in causing the extinctions? How did different ecosystems respond? These are legitimate scientific questions, and the research continues to refine our understanding. New evidence is being discovered all the time. New analyses are being conducted. The scientific community is working to develop a complete and accurate picture of what happened. But on another, deeper level, it's a profoundly human story. It's a story about how we respond to catastrophe. It's a story about survival and adaptation. It's a story about a moment when everything changed and people chose to keep going rather than give up. It's the story of our own origins, the story of how we became what we are. The people who lived through the Younger Dryas didn't have the luxury of despair. They couldn't sit down and feel sorry for themselves because the universe had disrupted their lives in ways they couldn't control or understand. They needed to survive. They needed to feed themselves and their families. They needed to find shelter and endure the cold and the darkness. So they did what humans have always done when faced with necessity. They adapted, they innovated, they transformed themselves. And in that transformation, they unknowingly set the stage for everything that came after. Agriculture, civilization, writing, science, technology, art, music, literature, all of it ultimately traces back to the forced adaptation that began when the sky turned black and the world caught fire. Without the Younger Dryas catastrophe, history would have unfolded completely differently. We might still be hunter-gatherers. We might never have developed agriculture or civilization or technology. The entire trajectory of human history was altered by an event that took place in the upper atmosphere over the course of a few hours. There's something almost poetic about this. The extinction of the megafauna was a tragedy. The loss of species that had survived the last ice age but couldn't survive this cosmic event was a loss to the world. Yet from that tragedy, something new emerged. New human possibilities, new ways of organizing society, new achievements and new cultures. The catastrophe destroyed an entire way of life. But from that destruction came something different and, in many ways, more complex. This doesn't mean we should welcome catastrophes. The Younger Dryas was a terrible event that caused immense suffering and death. Extinction is a tragedy. Climate disruption is devastating to ecosystems and the creatures that depend on them. Thousands of years of harsh conditions is not something to celebrate. But the example of the Younger Dryas survivors shows us that catastrophe doesn't have to mean the end. It can be met with resilience and innovation. It can lead to transformation. As we look toward the future, our own future, perhaps this ancient story has a message for us. Change is coming. Whether from climate disruption we're causing, from technological transformation, from resource depletion, or any other source, change is coming. We will be tested. We will need to adapt. The world we were born into will be different when we leave it, but we have within us the resilience of our ancestors. We have the ability to innovate and problem solve. We have the capacity to imagine new ways of organizing ourselves and new ways of living. We have the long view that comes from knowing that problems can take generations to solve. We have the wisdom that comes from understanding that we're part of a larger world, connected to ecosystems and climates and cosmic events that are bigger than ourselves. The day the sky turned black wasn't the end of humanity. It was a beginning. It was a catalyst. It forced change that led to everything civilization is today. As we face our own tests and transitions, we might remember that our ancestors faced catastrophe and survived. We might remember that adaptation is possible. We might remember that from darkness, light can emerge. The black mat in the geological record, that layer of soot and carbon and exotic particles, is a memorial to the catastrophe. But it's also a memorial to survival. It's a record of a moment when the world changed and humanity persisted, when the sky turned black and we kept going. We are here. That's the most important message of this story. Despite a catastrophe so severe, it nearly destroyed human civilization, we're here. Despite extinction pressures that killed off most large animals, we survived. Despite climate so harsh that entire ecosystems collapsed, we adapted. We're the descendants of survivors. We carry in our DNA and in our culture the memory of catastrophe overcome. Thank you for joining me on this journey through time, for walking with me through that ancient catastrophe and its aftermath, for sitting with the implications of a cosmic event that happened thousands of years ago, but shaped the entire course of human history. For considering what it means to be human, to be capable of facing the worst and finding a way forward. If you found this story moving, if it resonated with you, if it made you think about your own resilience or about the long arc of human history, I'd be grateful if you'd consider liking this video and subscribing to our channel. These stories matter, the history of our species matters, and by engaging with them, by taking the time to really listen and think about what came before us, we honor the experiences of those ancestors and we deepen our own understanding of who we are and what we're capable of. As you drift off to sleep tonight, perhaps you'll find yourself thinking about Abu Hureyra, about the Clovis hunters, about all those people who lived through darkness and found a way forward. Perhaps you'll carry with you the knowledge that we are descended from survivors, that resilience and adaptation run through our blood and through our culture, that even in the face of catastrophe, humans can find ways not just to survive, but to thrive and to create. The day the sky turned black was the day everything changed. But it was also a day that humans proved we could meet catastrophe with courage and innovation. That's a story worth remembering. That's a legacy worth honoring. That's the gift our ancestors left us, not just survival, but the knowledge that we can endure, sleep well, dream of ancient worlds and resilient peoples, dream of a future that we're capable of creating through the same strength that brought our ancestors through the darkness, and know that you carry within you the strength of survivors.